All right, boys and girls, welcome back to the drive-thru. We're here with special star Kennedy Bird, gonna kick off this video.
Hi.
Come on, you can do better than that.
Hi.
All right, Kennedy will be back. That's her first attempt at being at the drive-thru. Not bad, not bad. Okay. She's very nervous and she's talking like a bird, but that makes sense because that's her name. Okay. All right. This is an introduction into everything that you'll need to know for 5.1 and 5.2. You'll notice that we're going to do Chapter 5 relatively quickly because, again, most of it can be done in our graphing calculator. So, this is an introduction into polynomial equations. Polynomial, okay? That means many terms. Do you guys understand that poly just means more than one? So where have you heard that word poly before? Polygraph? Excellent. I don't know how it affects whether or not you lie, but that's certainly what a lie detector test is called, a polygraph test. Interesting. I don't know what that meant. Where else have you heard poly? How about polygon? Polyatomic ion. Thank you, Hannah. Thank you. What about polygamy?
Oh yeah.
Right? So all it means is many or more than one. So what is a polynomial equation? You've already been doing these. It's an equation with more than one term. You just got done doing polynomial equations, but now what's different is we're going to get higher than x squared. Okay? So first, what does it mean by standard form? Standard form means you need to write the terms from highest power to lowest power. So x to the 5th is the highest power and it's negative, plus 9x squared is the second highest power, minus 2x to the 1st. There is a 1 there, you just can't see it. And then plus 8. So that is standard form. How do you name it by the degree? This is the highest power. So we call this a 5th degree polynomial. Name it by the number of terms. That is called a quadrinomial. Or how about you just say 4 terms. Okay, either one of those is fine. Let's keep going. Oh dear. Oh dear. Oh dear. Oh dear. Oh dear. Here we go. What does it mean when they ask us to determine the end behavior of a polynomial function? Well, this is about graphs. And if you think about it, as long as the graph of something isn't a constant, there's only 4 options for how a graph can go. Okay? It can start low and end high, right? It could start high and end low. It could start high and end high. And what's the other one? It could start low and end low. Okay? So when they ask us to determine the end behavior, that's what they're asking. Okay? And honestly, how should we determine the end behavior? We should just pop these things in our calculator. So you can see that I have pulled my calculator up. We're going to type in 5 times x to the 3rd power. You see how this is going to be an important key now? and then I got to hit this over so I get out of the third power, or out of the superscript, minus 2 times x squared plus 1. Now, before I hit this, I want you to think about what you already know. Parabolas either start high and finish high, or start low and finish low. Does that make sense? Lines either start low and finish high, or start high and finish low. Well, the reason why that is that lines have an odd numbered power. The power on a line is a 1, whereas parabolas have an even number power. So, without graphing these, you can tell this one's odd. This number is not negative, so it is going to start low and end high. That's the end behavior. You would say low to high. Okay? Now watch. I'll graph it. Zoom. 6. Graph. Zoom. 6. Enter. And there you'll see it. Will it show up? No, it didn't show up. Right? Y equals. Oh, we're just slow. It's just slow. I'll pause. Okay, so we just had to clear that. But look, I was correct. It started low and it went to high. How did I know that? Well, I knew that because I'm a math teacher, but this is what you're here to learn. How does this number, the highest power, and this number, the coefficient on that power, affect the graph? Okay? So now let's look at number 7. Okay, hey, I don't like to keep people waiting, so I want to answer this great question that Kennedy just asked me. What if this 5 was negative? Well, what does a negative line look like? It goes from high to low, and that's exactly what would happen. If this was a negative 5x cubed, it would start high and end low, and we'll get there. This is what you'll be practicing, okay? All right, number 7 is one of those cruel, stupid math problems that are just trying to trick you, so don't fall for it. I want you to rewrite it in order of highest term to lowest term. Is our highest term positive or negative? It's positive, right? And is it even or odd? It's even. So without even graphing this one, you should know from the last chapter that it's going to look like that. And so we consider that high to high. Okay? All right, let's move on to the next page. So, how do we determine end behavior of polynomial functions? We look at the highest, move this out of the way. We look at the highest power and the lead coefficient. Or you can just put these in your calculator. Okay? So look, this says determine the sign of the leading coefficient and the degree of the polynomial. Well, here's how you measure the degree. You remember y equals x squared? Well, let me go back. Do you remember y equals x? What was the shape of that graph? It was a line, right? How many turns are there on a line? No, how many turns? 0. Right? 0 turns. Okay, what's this graph look like? Y equals x squared. It's a parabola. How many turns are there on a parabola? There's 1 turn. Okay, so maybe you see the pattern. The number of turns that a graph has is 1 less than the power of the exponent. Okay? So look at this graph here. How many turns do you see? 1, 2 turns. Excellent. So what is the power? This problem involves x cubed. And since it goes from low to high, what is the sign of the leading coefficient? It's positive. Okay? That's how we're doing these. So number 16 is harder. How many turns in number 16? 1, 2, 3, 4 turns. Okay? So what's the degree? It's not 4. It's 5. Remember, there's one more power than there is turns. Okay? Now, is it going from high to low or low to high? This one's going from high to low. So the leading coefficient is negative. And that's all you do on that. Okay? And number 17, you should feel great about. We just got done doing a whole chapter on these. How many turns? 1 turn. So what's the power? X squared. Excellent. And is the leading coefficient positive or negative? It's positive because that's going up, right? It's high to high. And if it was going upside down like a frown, it'd be negative. And so that is 5-1. 5-2 is even quicker. So now we are going to do this together. Okay, this is your worksheet. This is your assignment. We're doing the first one. So, what is the degree of this function? Well, the degree is the highest power. So what is the degree? 3. How many? Oh, okay. So what we'll call that is a third degree polynomial. Okay. How many terms are there? I'm sorry, not turns. You're right. We do not know how many turns. How many terms, like germs? How many terms are in this equation? There are 3. Y does not count. So that is called 3 terms, or even better, a trinomial. Tri meaning 3. What's the end behavior? Well, let's just graph it rather than, let's just put it in our graphing calculator. So we get, let's see, x to the third minus 8x squared. Oh dear. X to the third, I got to hit over. Minus 8x squared plus 16x. Okay? Graph it. So now we can see that there are 2 turns. Which we should have predicted. Okay? And let's use our table to find some points that we can graph. Okay, I had to readjust my window, sorry. Max, I'm going to take your question in just a second, okay? Notice, this thing gets really big and really small really fast. So we can only really graph a small part of it. So we'll say that 0, 0 is on there. And we know that -1, -25 is on there, so it's just like way down there. So I'll just put it down there. Okay. Sorry that I got to keep toggling. We know that 1, 9 is on there. And we know that 2, 8 is on there. And let me just scroll down. We also know that 3, 3 is on there. Four, 0 is on there. And 5, 5, and then it just screams up from there. So now what we're going to want to do is take another look at the graph and just try to match the graph. Got it. So without that graph, it'd be really hard. Now I want you to imagine this is where we are screwing things up. Why did they used to teach like end behavior? Because the student couldn't even imagine what this graph would look like. And now we can because of graphing software. So the graph looks like this. Okay? So end behavior, we can just say this. Or we could say low to high. Okay? Factored form. This is going to be the one that my class is going to have the hardest time with. We don't do a lot of factoring, but it's okay. Do you see how I took this and factored out an x? Can you see that? I just took an x out of every one of these terms. Now, what's inside here, you might be able to factor. And if not, you can use that John Rick formula. The John Rick thing in your calculator. So, this is the same thing as x times, I'm looking for two numbers that multiply to be 16 and add to be negative 8. Nope. Negative 4, gosh, and I wrote down 5. Negative 4 times negative 4. So that is the factored form. I'm just screwing this up. Okay? Where does it hit 0? This is why we ask you to do the factored form. It hits 0 at 0. And where else? At 4. And maybe you recognize why that is from the factored form. That's why the factored form is helpful. Multiplicity, just say 4. Well, actually, just skip the multiplicity part. I don't even care about that at all. I truly don't care about it at all. The relative max, well, we're going to have to, oh, that'd be a good nickname for you. The relative max? No? You can be the relative min. No? Alright, hey, this is why I'm pumped up about this class. Everyone else is going to struggle with the relative max, and I feel like my class is going to do great. How are we going to find this thing right here? We are going to calculate. What are we going to calculate? The max, 4. And we get to the left of it and hit enter. And then we get to the right of it and hit enter. And then it says, would you like for me to take a guess? You're darn right I do. And that is 1.3 repeating, comma, 9.5. Okay. What is the relative min? Well, the relative min I can actually pull right off of my graph. Oh, it's 4, 0, Kennedy. Be careful. And now you are literally ready to practice 5-1 and 5-2. Okay, so the rest of this week you're going to spend practicing, and then you'll hopefully take your quiz, you know, end of the week, beginning of next week. Can I get a boom? 6th bell? Boo! Boo! That was terrible.